A very good morning to all the students and welcome back to our course on the C programming language. In today's session we are going to discuss about one important topic, very important topic in the entire C programming language, perhaps in the entire functions concept of C, that is parameter passing mechanisms. Right. We know what these parameters are. These parameters are otherwise called as the arguments. We have done one particular session on the arguments. An argument is nothing but a variable which can hold some values. And why it is called as arguments means these variables are used to pass information from one function to another function. So we have two types of arguments as we have seen in the earlier sessions. One is the actual arguments. These arguments are the variables that are declared inside the calling function. And the second one is the formal arguments. These are the variables that are declared inside the called function. Right. Now, why we require these parameters to be passed from one function to another function? Why we are passing these arguments means in order to invoke or in order to make the communications to happen between two functions. So if two functions want to communicate with each other, they should pass some information. And how they are going to pass the information means by making use of these arguments. All these things we have seen. Now our topic of interest in present session is the parameter passing mechanisms. Basically in C, the parameter passing mechanisms that are supported in C programming language is of two types. The first one is pass by value and the second type is pass by address. Pass by address is also called as pass by reference. There is a small difference between the pass by address and pass by reference, but this particular concept we are not going to discuss in today's session. This is for the understanding of this pass by address, it requires the concept of pointers. So the concept of pass by address has been postponed till the discussion of the pointers. Now, out of these two types of parameter passing mechanisms, we are going to discuss about the pass by value in today's session. So by looking at these names, you can simply identify that the first mechanism, that is pass by value, means you are going to pass the value of the actual arguments to the formal arguments. And coming to this pass by address, you are going to pass the address of the formal arguments which are to be stored inside the formal actual arguments. Address is passed where the formal arguments will be storing those addresses. Right. How we are going to throw the address, how we are going to store the addresses, all these things we will discuss at the concept of pointers. So, in today's example, let us confine our discussion towards the pass by value. So when pass by value means, you can simply say that you are going to pass the value. You are going to just pass the value from the actual argument to the formal argument. That means the values are copied from the actual arguments to the formal arguments. At the end of the session, we will discuss very important point regarding this pass by value. Why this pass by value is important and what happens during this pass by value. right? So let us start our discussion with a programming example. Let me write a program here. Please give me 2 minutes of time. Right. So are you able to see the screen? This online compiler, are you able to see? Say yes or no? Okay, thank you. So I am going to write a program on swapping of two numbers using a temporary variable. We know very well about how to swap these two values, right? Using temporary variable. The concept is very simple, and we are all very familiar with this particular program, right? But right now I am going to write a program using pass by value. So what is the first thing? Hash include stdio.h. This is the preprocessor directive, and I start my main function, right? And here I am going to take two variables of type integer, int a comma b, and let me prompt the user to enter the value of a, printf \n to print it in new line. Please enter the value of a, right? And I am terminating with the statement terminator. Now I am going to read the value. Scanf. Since I am reading the integer value, I should make use of the format specifier as %d. Okay, and here I have to make use of the address operator of a. Now I am ready with the value of a. I repeat the same thing for b. That means I prompt the user to enter the value of b, and I am reading it into the variable b, right? So let us say a is having the value of 10 and b is having the value of 20. At this point, this is called as the declaration statement. The memory will be allocated for both a and b. I will explain it again, right? Now after reading the values of a and b, 10 and 20 respectively, I am going to call a function to swap. So I am writing the name of the function as swap. So how many values you are swapping? Two values. So you have to pass those two values. What are those two values? Where you have stored these two values? They are being stored in a and b respectively. So I am just passing this swap. I am just calling this function swap with two values or variables a and b respectively. So this a and b are called as the actual arguments. The actual arguments are those arguments which are declared inside the calling function. So main is the calling function. Main is calling swap. So main is the calling function. Let me write it. This is calling function. And what about this function swap? Swap is called function. What is this statement called? This statement is called as function call statement. So at the function call statement, we know that the control will jump from this part to the function definition. So let me write my swap function definition here. So the function definition means, again I am recapping it, right? I am recollecting the concepts. Function definition means you have to write the header as well as the body also. Header includes the return type, function name and the list of arguments. Here in swap, I don't specify any return type. Listen carefully, one of the important concept or one of the important question you may have is, sir, if you don't specify any return type for a function, what is that it is going to take? Means it is going to take integer as the return type. So the default, very important question, somebody may ask you, what is the default return type of a function? So you can say that the default return type of a function is integer. Right, very important viva question, interview question, whatever it may be. Right, very basic questions, you should be aware of this question. Right. So what happens here is swap. I am not specifying any return type for this swap. So it will take it as integer return type. So the default return type of any function is swap. Right. Now let us write the swap function. Swap. Since I am throwing two values from the calling function main, there should be two variables to catch hold of these variables, that is int x comma int y. Now I am taking another temporary variable. Now we know the logic, right? Temp, I am storing x in temp. Y is equal to x and x is equal to 10. Sorry, temp is equal to x, y is equal to x, and we store temp in y. Sorry, x is equal to y and y is equal to 10. So this is the logic for the swapping of two variables, right? So let me write the statements here. Let me write the printf statement. The values of a and b before swapping are a is equal to address g and b is equal to percentile b, a comma b. Right. So this is, I am just printing the values of a and b before swapping. Now after swapping also I will write the same statement. Right. This is in main function. So let me write it as to identify the things: main function before swapping and main function after swapping. The same things I will write it for the same swap function also. Let me copy it. See, after temp, let me print it here. This is not main function, this is swap function. Right. And after swapping, let me print it out. Swap function. This is after swapping. Right. So this is how I have written the swapping of two variables in C using temporary variables. What I did is I am writing the main function, taking two variables a and b. I am prompting the user to enter the value of A, reading the value of A. Similarly, prompting the user to enter the value of B, reading it into the variable B, and before swapping, calling the swap function, this one. I am just printing the values of A and B. And once the function is called here, I told that you are going to pass the control from the calling function, that is main, to the function definition. The control will jump from here to this point here. While control is jumped from that place to this place, the values are also copied. So 10 and 20 are also copied, and they are stored inside this X and Y respectively. And here I am taking a temporary variable. Before that I am printing the values of this A and B, copied values. So X and Y. So the point you have to observe here is, at this particular point of function call, the control is jumped along with the values which are copied from the actual arguments to the formal arguments. So A and B values 10 and 20 are copied. Listen carefully. The values of actual arguments 10 and 20 are copied into the formal arguments. So since you are copying the values of the actual arguments to the formal arguments, this concept is called as the pass by value. You are passing the value. You are copying the value of actual arguments to formal arguments. So this is called as pass by value. At this point I am just printing the values of X and Y before swapping, and after swapping I am printing the values of X and Y. I am naming it as A only, but right. Let us execute this one. See here, what is the warning I got here? Of course the program has been executed. I got the output as please enter the value of A, but the warning I got here is, in function main, implicit declaration of function swap, right? Here the return type defaults to int. This is just warning it, right? So what we are doing, what we can do to avoid this is, see here, I just make the return type of swap as void. Since it is not returning anything, I make it as void. And you have forgotten to give the function declaration here, void swap int comma int. This is enough, right? So function declaration is given, and I have given the name of the function, return type of the swap function as swap. Let me run this program. See here, main, again it is giving a warning on main. This is just a warning, it will run, right? But here what can you do is, you can give it as main, int main. Now let me run this program. See here, now I am not getting any warnings here. So the first thing is, I am taking the value of A, which is 10. Now the value of B is 20. See here how it is going to execute. So this statement is executed. Main function, the values of A and B before swapping are 10 and 20. Right? This one is executed. Okay. After this, the swap function is being called. I told that whenever you have a function call, the control will jump from that statement, function call statement, to the function definition. So control will jump from this statement, function call statement, along with the values of 10 and 20, which are copied into X and Y respectively, and from here onwards the execution takes place. So at this point what happened, I am taking a temporary variable and this statement will be executed. You can see here the second one. In swap function, the values of A and B before swapping are A is equal to 10 and B is equal to 20. And I have given the logic of temp is equal to x to swap these two values. And this statement is executed later, which says that swap function, the values of a and b after swapping are a comma b, that is x and y. See here, you can observe that the values of a and b have been swapped. Previously in the swap function, a is equal to 10, b is equal to 20. And after swapping, a is equal to 20 and b is equal to 10. Okay, up to here we are clear. And after executing the last statement, it will execute this closed brace, and since this is the end of the function, the control will again jump back from this called function to the calling function. So after swap, this will be executed. So this is how the function call state takes place. Now this statement is executed. You can see here, main function, the values of a and b after swapping are, see here, again it is saying a is equal to 10 and b is equal to 20. The values are not swapped. The values are swapped inside the swap function, but the result is not reflected in the original variables a and b. Previously, before swapping, the values of a and b are 10 and 20. And in the main function, after swapping, the values are of a and b are 10 and 20 respectively. The values are not swapped. What is the reason? The reason is that during function calls or pass by value, if you are making use of the parameter passing mechanism as pass by value, the modifications that you perform in the called function will not be reflected in the calling function. So this swap is a called function, right? Listen carefully, this is very important point. This swap is called function. Right? Whatever modifications that are done in the called function, they are limited to that function only. They have their scope up to this function only. Once they come out of the function, that means once this closing brace is executed, once they come out of this function, their values are dead. That is called as the scope of variables. We will see it in the concept of another concept that is related to C. The scope, lifetime and default values, everything we'll discuss in another topic, right? But right now you just remember that whatever modifications you perform in this swap function, they are limited or they are confined to this function only. The modifications that are done in the called function are not reflected in the actual parameters. So whatever modifications you do in this formal parameters x and y, those are present within the swap function only. They are not going to reflect the actual parameters. So important point, last and important point, modifications that are performed in the formal arguments are not reflected in the actual arguments. Actually, this is one of the disadvantages we have with the pass by value mechanism. For this reason, we are making use of, to avoid this problem, we are making use of pass by address. That we will discuss it in the next session. But right now, remember that modifications done on the formal parameters are not reflected on the actual parameters. So that is the reason why whatever modifications you do this for this x and y has been changed 20 and 10. From 10 and 20 they have been changed to 20 and 10. But once this function completes its execution, once the control goes from here to here, the values of a and b comes into existence, not the values of x and y. The values of x and y are dead. They are literally dead. They doesn't retain their values. They are dead variables. The x and y, the formal parameters, are dead variables once the function is completely executed. So that's why those values, when you come back to this calling function main, the x and y does not take place. The x and y, they won't have any effect. So the original values of a and b are 10 and 20 only. So it is going to print a and b values as 10 and 20 respectively. So we can see here that the main function is having two variables, right? This is a and this is b, which is having 10 and 20. And from here I am calling the swap function, which is called as called function. Here I am taking the variables as x and y. So it is 10 and it is 20 initially. After making the swap operation, the values of x and y becomes 20 and 10 respectively, right? And when you print the values after swapping, the x and y becomes 20 and 10. But once this swap function is completed for its execution, when the control jumps from here to here, the variables x and y are dead. This x goes away and y goes away. These are completely dead variables. So once you come here, again when you try to print the values of a and b after the swap function call, the values that are present inside this a and b are 10 and 20 only. So 10 and 20 will be printed. So by this you can understand that whatever modifications you perform in the formal parameters, they are not going to affect the actual parameters. This is very important point you should observe in the pass by value. So in today's session we have seen the concept of parameter passing mechanisms. We have seen what the arguments are, what are the two types of arguments we have, that actual and formal arguments, and why we require these arguments. For communications to happen between two functions, we require these arguments. And what are the two types of parameter passing mechanisms we have is the pass by value and the pass by address. So pass by value, we have gone through an example of swapping two numbers, where the important point we have learned in today's session for this pass by value is, the first point is pass by value is a mechanism that is used to pass the values from the actual arguments to the formal arguments. That means the values of the actual arguments are copied into the formal arguments. That is the first point. And the second point is, whatever modifications you do to the formal parameters, those are not reflected to the actual parameters. So the formal argument modification does not have any effect on the actual arguments. These are the two important points, very, very, very important points. Values copied from actual arguments to formal arguments. Second important point is modifications to formal arguments has no effect on actual arguments. Very, very important points. So by these important points and the discussion with a programming example, I conclude this session, the pass by value mechanisms. In the next coming session, we will discuss the concept of pass by address, which is postponed after the discussion of the pointers concept. Thank you one and all for joining the session.